see, controller is transmitting A continuously, and we use a software which is something similar to hyperterminal. Have you heard about hyperterminal before? No?
No, sir.
No. I think it is a software which can read data from serial port. Okay.
Okay.
So what happens now? The microcontroller board that we have is transmitting A continuously after initializing a serial port. The software that we have in our laptop is communicating with the microcontroller via a hardware cable, prolific USB to serial port interface. Right? So now my laptop acts like a one serial device, and microcontroller board, motherboard that we have now, that acts on another serial device. So my laptop also having the serial port using the prolific cable, and by default in motherboard we have a serial port. So when we attach both of them, so the microcontroller transmit A in TX line. That means serial TX line, packet by packet. So as we discussed before, serial communication interface packet will carry 1 byte in a packet. The A is coming from there. The software that we have in the laptop now, it is monitoring the serial port. If something is received, it captured that in RX register. Once it captured that in RX register, and then it put that in the screen. Whatever that it received, no, that is displayed in the screen. This is how this program works. So if you want to see the program that we had before, this is the program right now. Actually, in this program, we have a flaw, a small mistake is there. I will tell you by referring the what mistake it is. So because of that mistake, let us see what happens in our transmission. So this is our terratom. Now what I do, I just cut off the power to the microcontroller board, so the message coming from board stops.
Yes.
Right. Again, I turn it on. So I get A continuously. This is perfect. This I made a power reset using the switch that I have in the motherboard. Now I press the reset button in the motherboard. Let's see whether I am seeing any behavioral change. Even when I press reset button, I don't find any different. So it's doing the job.
Yes.
Right?
Yes.
So it's doing things. Now I turn off the main power that I supply to my adapter. I have an adapter which is downgrading 230 volt to 12 volt DC, meaning it is doing a conversion. So I just turn that off. Even now the message is stopped. So again I turn it on. So it's continuing that text. But sometime in an abnormal situation, instead of A, I get P. Maybe the communication looseness in the cable or some issues. I am not getting A always. Sometime, very rarely, very seldom I find this P instead of A. That may be, for that there are many reasons, right? One among them is the looseness in the cable, and then it can also be the flow in which I transmit the data. That can be a issue as well. So in that line, what I find the issue in the code is we are initializing TX register to 65. Before doing that, we initialize the serial port. Yes or no? The moment they come inside this main function, they will call this init serial port. In init serial port, at the very end, we enable the transmission enable. Like we do many things. We disable all interrupts, and then we configure port C, 6th pin as output, 7th pin as input, and then we select the high baud rate. We configure the baud rate 9600. We make the asynchronous communication by setting the sync bit to 0. And then we enable the serial port. We disable the transmit interrupt. We also disable the 9-bit transmission. Finally, we enable the TX. Right now.
Yes.
Right. Finally, we enable the TX. One second. But before enabling the TX, we have to give some word to TX register. We have done here now. Actually, what we are doing, we initialize the serial port first, and then we give the value to 65, TX register 65. The moment you enable the TXEN, what will happen means whatever the content that we have in the TX register will be transmitted. If, let us say, if it is having 0, that will be transmitted. That is not obviously correct. We have to give the data that we really want to transmit first, and then only have to enable the transmission. Right now. So that is a gap here. That is the gap that we have here. Right. So that we can address. After doing it, because of that, what happens is, as we are enabling the TX, we enable TX before we give actual value to TX register. It simply transmit whatever the junk value that we have in the TX register. That is wrong. So we can make this, we can put this here, and then we can try. Other than that, the flow is correct. Shall we try like that? Right. So do you understand the program now? What this program actually does? What
Yes.
it could you explain what it does actually?
So we are initializing the serial port
Mm-hmm.
using different the
Configuration registers.
configuration registers.
Hmm.
And after that, we are sending that 65. That is in character it is 60A.
Yeah.
So that will be transmitted in the serial port.
Yeah.
Infinitely, like
Infinitely.
while loop.
As what we are checking here, can you brief what? See, while true, that means that means you do it always. After that, we are checking PIR1 bits TXIF. What it really, why we check that one? We are checking it for what? We check whether it is equal to 0. Because we put a not symbol in front of that register bit, no.
Yes, sir.
Meaning that we are checking if it is 0. If it is 0, they will wait. If that bit is 0, they will wait. Moment that bit becomes 1, meaning it is empty. How we come to know empty? That is what told here. See here, read the passage here. USAR transmitter block diagram is shown in figure. Heart of the transmitter is transmit shift register, TSR. It is not in our control, right? Shift register obtains data from read bar write transmit buffer. TX register. TX register is a transmit buffer. When you want to transmit something, you have to store that value to TX register. That is what told here. So from here, where it goes to TSR. TSR is a register which shifts the bits of the word that we want to transmit serially, one by one. Right now, that is what its job. The TX register is loaded with the data in software. That is what we initialized. TX is equivalent to TXR is equivalent to 65 we gave, no? So which is nothing but we are initializing that TX register with some value. TSR register is not loaded until the stop bit has been transmitted from the previous load. So if the TSR register is not refreshed, that means refreshed until the stop bit is received. Stop bit means your previous packet was successfully transmitted. Okay, you can ask me a question. Okay, if we are doing a very first time, so in very first time, they will simply transmit the value. They won't look for this stop bit. Okay, now. So as soon as stop bit is transmitted, TSR is loaded with the new data from TX register. Right, it will get the data from TX register. Once the TX register transfer the data to TSR register, right? The TX register is empty. The moment the word goes to TSR register, TX register is empty and flag bit TXIF is set. Moment it becomes empty, it will set the TXIF. Right. This interrupt can be enabled, disabled by setting the setting bar clearing enable bit. So when we set the TXIE bit in the PIE1 register, when the transmitter is empty, it will generate an interrupt. When you generate an interrupt, program counter will be loaded with the program memory address 4 as per this particular controller, because the interrupt vector is a single address in this particular microcontroller. It will be loaded with 4. So in 4, you can check what you want to do. Understood. But you don't like to, even though you disable this TXIE bit to 0, even though you disable this particular bit to 0, the TXIF bit flag is set no in this particular register.
Yes.
PIR1 register, this fourth bit is set no. That
Yes.
will happen even if you disable TXIE. Meaning that if the transmitter is empty, TXIF flag will be, this bit will be set to 1, right? Even though whether you enable the transmit interrupt or disable the transmit interrupt. If the transmit interrupt is enabled, the program counter will be loaded with 4. Once the TXIF flag is set to 1. If the transmit interrupt is disabled, even in that time TX flag will be set if the transmitter TX register is empty. But the program counter is not loaded with 04. That is the only different when you get when you disable the transmit interrupt. Do you understand the point what I am trying to say? Yes or no?
Yes, sir. What I understood is like when the register is empty, it will be set to 1.
When the TX register is empty,
yeah,
the TXIF flag will be set to 1.
set to 1.
Irrespective of whether you enable the interrupt or disable the interrupt. Okay, when I enable the transmit interrupt, what will happen? The moment that flag is set to 1, program counter is loaded with 04. 04 is a program memory address, which is called a interrupt vector. So there you can decide what you want to do when this transmit interrupt happens. Usually they won't do that in a single line. There will be a program call in that 04. They will go there. In that function, they will check whether which flag is set. Based on that, they will do different things. But when you disable that in that particular TXIE bit, the TXIF flag will be set to 1. That will happen for sure. But the program counter is not loaded with 4. That is the difference. Understood?
Yes, sir.
Will be set regardless of the state of enable bit TXIE and cannot be cleared in software. We cannot clear this bit to 0 or 1 in software. That will happen automatically. It is in the control of the microcontroller. We need not go and set that bit. Instead, we will check that bit. TXIF flag, we can simply check, but we cannot set any value to that bit. That is what they are trying to say here. It will reset only when the new data is loaded to the TX register. Moment you load a new data to TX register, at that point, the TX register will be, the TXIF will become 0. So as per this flow, when I load 65 here, the TXIF flag will be 0. Right now. After that, I will come inside the infinite loop. In that infinite loop, I check. What I check? I check TXIF. What will be the value of TXIF? Value of TXIF will be 0. Value of TXIF will be 0. Why? Because I loaded the TX register with the 65 here. Yes or no? Right. So as it is 0, what will happen? What will happen? It will wait as long as it is 0 in this while loop. That means inner while loop. Infinite wait. How long? At one point of time, when you put some word to TX register, it won't keep it forever. It will transfer that 65 to TSR, transmit shift register. All 65 will go there. Moment that TXR register get the content, TSR register get the content, what will happen? The TXIF flag will be set to 1. At that point, it will come to this line. Up to that time, it will wait here in line number 25. Once that flag is set to 1, which means that it is empty, it will come here. It will come and will load the TX register value to 65 again. Moment the TX register value get the 65, what will happen? Again the TXF flag will become 0. As it becomes 0, because after this we don't have anything, so it will come for next iteration. It will check for TXIF is equal to 0. If it is 0, it will wait there. The moment it become 1, the condition fails, it come here and load the TX register to 65. So it keep on repeating this step. When it repeats this step, we get a infinite transmission of 65 from the microcontroller. So when it is transmitted, the software that we have in this particular laptop is receiving it. How to set up that software? You can get this software from internet. You can search for Teratom. So when you do like that, you will get this software. Okay, let me close this. Right. So when I open it, I will get a shortcut like this in my laptop, just desktop. So just select that, just open it. After open it, you choose serial. In serial, you can say which port it is you have connected. Whatever port that you have a valid serial device, that will be listed here. As I connected the prolific cable in COM3, it will listing the COM3 here. So I selected that and click OK. So if you see here, now I am getting P. Actually, what I have to get? I have to get A. That is what expected. I am getting P. This is due to sync issue. So I am going to resolve that by turning it off and then bring it again. So now it is displaying A. Understood? Because sometimes the sync will not happen between the software and the microcontroller. To solve that, you just issue a reset from the motherboard side. When you issue the reset from the motherboard side, automatically it syncs with the software. Right now?
Yes, sir. Cable you used USB to.
It is like USB to serial prolific cable. 2303, I believe this is the spec. You can actually, this driver was missing previously. Now we got that driver. PL2303 prolific USB to serial driver. I just paste this. Right. I think that is sold in everywhere. There are some fake cables as well in this one. Please check whether you have a prolific logo in that product. Only then you buy it. Let me explain the first flaw that we have in our code. the first flaw that we have in our code is we are initializing, we enable this transmission before we actually load the TX register. Right. So maybe what we can do is I initially make this bit to 0 in the init part. After that, once I loaded the value here, right, and enable the transmission. I can do like that now. This is the first fix I can do. Right, initially I initialize the serial port but doesn't enable the transmission. After that, I load the TX register with the 65, then I enable the transmission. This is the perfect flow as per this document. After that, I just check here whether the TX register is empty. What actually the TX register will do, if I put some value in TX register, that will be transferred to TSR register, transmit shift register, which is the one which is shifting the bits out. After I check the TX register is empty, I go and load the 65. Actually, this is somehow wrong because the content of TX register is gone to TSR. I didn't check whether the TSR is empty. Only if the TSR is empty, only then I have to load a next word. Yes or no? Because I maybe the TXR is shifting the bits in between. By that time itself, I load the TX register with the 65. That is not right way of doing thing. So I have to check that TSR register is empty. How can I check that? For that only they have this bit. While the flag bit TXIF indicate the status of TX register, another bit TRMT, which is the first bit in TXSTA, shows the status of TSR register. The status bit TRMT is read-only bit which sets when the TSR register is empty. Meaning, if the TSR register is empty, that particular bit will be 1. TRMT bit will be 1. If the TSR register is full with the content or partial content, then that bit will remains in 0. So, which is something similar to TXIF. Yes or no? So also they are saying no interrupt logic is tied to this bit. So the user has to poll this bit in order to determine if the TSR register is empty. There is no interrupt associated with that. So they have to poll that bit to determine whether it is empty or full. Understood? So we are going to include that logic as well in this code. For that, what I can check is, and I can put an and TS STA bits dot I think it is looking this TRMT, right? Even that is equal to 0. TXIF is 0 and TRMT is 0. If both are 0, you wait for here forever. Moment they both becomes 1, meaning they are empty, then you load a new value to this one. Do you understand now what I mean? Do you understand the change that we made in the code? What we are doing now, what we did before?
Yes, sir. We are using this TXTA bits. Previously we are not included in the code.
Previously, we tested only the TX register is empty. Now we are also checking the TSR register is empty. If TSR register is empty, only then we load the value to TX register. So the moment I put the value to TX register, these 2 bit will become 0, because why? Initially, moment we put a value to the TX register, that will be transferred to TSRS register. As we have the content in both of them will become 0. Right. The moment both of them become 1, meaning they are empty, meaning that at that moment the entire transmission has been completed. Once it is completed, again I load with a new value. Right. So that's how it is. Let us check whether this works now. So I save this and then I build. So init serial port, we have done prototype here. Now we are getting a warning. Direct function call made with an incomplete prototype init serial port. Why it is so? We have created a prototype here, and then we gave the definition as well. So now let me remove the microcontroller from the board and I connect that to flasher. Right, it says pick it to found and connected, pick device found, it is listing the device, everything is coming. So what I am doing, I just initially try to read the content in the microcontroller, right? And I got that content. After that, I want to erase it and I write that empty words. Perfect. Then I load X file, import X. So here is X file. I just select that and I open it. Right, then I write that right now. Connected now. Then I turn on the power and I bring, okay. So there is no difference. We get the A again without any problem. Let us try now. I turn off the power and then I turned off the main power now. Even now previously we have a struck up, right? It was trying to transmit P. After issuing the reset only we got A. That problem doesn't happen now, right? Now I turn off the power in the board and turn it on. I issue resets in the motherboard. So everywhere I get a same result. So now the program robustness has been increased. Clear? Hello.
Yes, sir.